All right, let's go. Number 10, the acorn. It falls from the oak by the million. Across the northern hemisphere, the acorn has been one of the most abundant wild foods on the planet. For most of human history, it was also one of the most important. In prehistoric California, in Jomon-era Japan, in Neolithic Korea, along the Mesolithic coasts of Europe, the acorn was not a snack gathered by children. It was a staple. Whole peoples built their calendar around the autumn-fall of oak mast and stored it in pits and baskets to carry them through the winter. And yet, in its raw state, it is close to inedible. Bite into a fresh acorn, and the mouth turns to sandpaper. That dryness is not a texture. It is chemistry, and it is a warning. Acorns are loaded with tannins, the same class of compounds used for centuries to turn raw hide into leather. In the mouth, those tannins go to work on the proteins in human saliva, binding to them and pulling them out of solution. That puckering, cottony feeling is the sensation of the mouth's own lubricating proteins being stripped away and clumped together. Swallow enough, and the effect moves inward. The tannins that matter most in acorns are the hydrolyzable kind, the group that includes tannic acid, and these are absorbed rather than passed through. In quantity, they interfere with digestion and bind up minerals. They can cut the body's absorption of iron by half or more, and they load the kidneys and the liver. There is a reason the animals that die from oak are livestock. When acorns dominate a cow's diet, the animal can bleed internally, and its kidneys can fail, and every autumn brings a scatter of poisoned cattle across European pasture. Human beings almost never reach that point, but that is not because the acorn is harmless. It's because our ancestors solved it. Here is what makes the acorn belong on this list. The danger was never a quick death. It was a locked door. One of the richest food sources in the temperate world sat behind a chemical wall. The only way through was labor and knowledge and time. Prehistoric people learned to leach the tannins out. They ground the nuts to meal and rinsed them in running streams for days. In California, they poured warm water again and again through the meal spread over a shallow basin of clean sand, letting the sand filter what the water carried off. Others boiled the meal through many changes of water. Others buried it in cold mud all winter, or treated it with wood ash to break the bitterness with lye. At a waterlogged site called Higashimyo in southern Japan, archaeologists uncovered storage pits roughly 8,000 years old. They were packed with acorns and lined with the oldest basketry ever found on the islands, baskets that seem to have been used to soak and hold the nuts. Modern chemistry has measured what that patience buys. A cold water soak, changed daily over 2 weeks, strips away most of the tannin and leaves the starch intact. Boiling is faster and less thorough, and done carelessly, it locks the bitterness into the flour instead of drawing it out. Every one of those methods is a piece of technology, not a tool, a procedure, remembered and handed down, that turns a poison into bread. That is the quiet danger of the acorn now. The nut has not changed. We have. Almost no one alive today could take a sack of raw acorns and make them safe without looking it up first. The knowledge that once fed whole nations has thinned to a hobby. The oak still drops its harvest every year, onto ground where the people who knew how to read it are gone. The food remains. The instructions were mostly lost. Number 9. Bog butter. In 2011, 2 men cutting turf near Tullamore, in the Irish Midlands, drove their tools into something that was not peat. It lay 2.5 meters down. It was a mass of pale, waxy fat, sealed inside a carved wooden keg with a fitted lid, and together they weighed close to 50 kilograms. It had been buried a very long time. When the lid came off, it still carried a faint smell of dairy. This was bog butter. Ireland's peatlands have surrendered hundreds of these deposits over the years, some in wooden vessels, some in baskets, some simply packed into the wet ground in a skin. For a long time, the finds were curiosities. Then a team from the University of Bristol and University College Dublin, working with the National Museum of Ireland, took dozens of them into the laboratory. Their study, published in 2019, read the fats molecule by molecule. It dated the deposits across 4,000 years of Irish history. The oldest they could pin down came from a bog in County Offaly in the early Bronze Age, around 1700 years before the Common Era. The practice ran from there up toward modern times. The chemistry answered another question too. Most of the Irish samples were true dairy butter, and follow-up work at Trinity College. Dublin pulled cattle, DNA straight out of the ancient Greece. What the bog does to buried fat is its own slow alchemy. Sealed from oxygen in cold, acidic peat, the butter does not simply keep. It saponifies, the fats breaking apart and reassembling into something closer to soap. The result is a firm, grayish, waxy substance called adipocere, the same material that forms on a body preserved in the same ground. The scientists who have smelled it reach for words like rancid, gamey, worse than old cheese. It is recognizably the same stuff that went in. It is also by then no longer really butter. So why put it there? That is the part no one can answer cleanly, and the researchers refuse to force it. The practical reading is plain. A peat bog is a natural refrigerator, cold and airless and sour, and butter was wealth in early Ireland. It could be stockpiled, even handed over to pay what was owed. Bury it at the summer pasture, retrieve it later. But storage does not explain everything. A striking share of the Iron Age deposits were placed with deliberate care, in fine vessels, in boundary ground. They lie in the same wet, in-between places where earlier people had cast swords and gold as offerings. Some of this butter, it seems, was never meant to be dug up again. In one reading advanced by the museum's own archaeologists, many of the deposits sit along old tribal boundaries, as if the butter were a claim staked in the wet ground at the edge of a territory. And that is the unsettling thought at the center of it. Somewhere under the Irish bogs is fat that a person churned 3,500 years ago, carried out into the marsh, and gave to the ground. As for eating it, a few archaeologists have tasted small amounts of the younger finds and lived to tell it. The online legend that bog butter is a botulism trap does not really hold up, because the sourness of the bog is exactly the kind that keeps that bacterium from growing. The real danger is simpler and stranger. It is millennia-old animal fat, half turned to soap, that still looks enough like food to invite a taste. It survived because nothing in the bog could rot it. The people who made it did not last nearly so well. Number 8. The honey that maddened an army. In the spring of 401 BC, an army of 10,000 Greek mercenaries was fighting its way home along the southern shore of the Black Sea. They were near the old colony of Trebizond, in what is now northeastern Turkey. They were exhausted and half-starved, and the country was full of beehives. The soldiers raided the hives and ate the combs. What followed was recorded by their own commander, Xenophon, in one of the strangest passages in ancient writing. The men who had eaten the honey went, in his words, out of their senses. They vomited. They purged. They could not stand. Those who had taken a little seemed violently drunk. Those who had taken a lot behaved like madmen, and some like the dying. They lay strewn across the ground, Xenophon wrote, as if the army had lost a battle. 3 or 4 days later, they got up and marched on. No one died. The honey was not spoiled. It was doing exactly what its chemistry demanded. On that coast, the bees feed heavily on wild rhododendron, and rhododendron nectar carries a family of compounds called granotoxins. Granotoxins jam open the sodium channels that nerve and muscle cells use to fire and then reset. The cells cannot switch off. They stay locked open, and the body's own signals to slow the heart pile on top. Worked out in modern pharmacology, the result is a steep drop in blood pressure and a dangerously slow pulse, along with dizziness, collapse, and the scrambled senses Xenophon watched sweep through his men. The effect can take anywhere from 20 minutes to a few hours to arrive, long enough that a person may finish the whole comb before the first wave of dizziness lands. The name for the stuff on that coast, then and now, means mad honey. It has been used as a weapon more than once. Around 65 BC, the geographer Strabo records, a hostile people on that same shore left combs of the crazing honey along a road where Roman soldiers under Pompey were marching. The Romans ate it, lost their senses where they sat, and were cut down while they lay helpless. Strabo says 3 units were wiped out this way. The honey did not have to kill anyone. It only had to make an army stop being an army for an afternoon. But here is where the story stops being ancient. Honey is one of the oldest foods our species ever took from the wild, painted on cave walls 8,000 years ago. Wherever rhododendron grows thick, this danger has come with it. It did not begin with Xenophon. He was only the first to write it down, and it never stopped. On the Turkish Black Sea coast, dark, bitter, mad honey is still made and sold on purpose. It is prized as a folk remedy and taken by the spoonful. Every year it lands people in hospitals with their hearts crawling along near 40 beats a minute. One large review gathered more than 1,000 modern cases. The pattern barely changes. A collapsing blood pressure, a heartbeat dropping toward a stop, and then, with the right care, full recovery. The remedy is almost absurdly simple. A dose of atropine to lift the heart rate, fluids to raise the pressure, and a patient who a century ago might have died walks out within a day. Almost no one who reaches a doctor dies. Most of those cases come from Turkey, but the wild honey of the high Nepalese cliffs, drawn from the same kind of rhododendron, carries the same jolt. So how is a thing this dangerous still sitting on shelves? Because it does not look dangerous at all. This is not poison hidden in something exotic. It is poison hidden in honey, the sweetest and most trusted thing prehistoric people ever gathered, and it looks identical to the honey on any table. A jar of it looks like breakfast. It comes from flowers. And in the wrong valley, at the wrong strength, it can put a grown man on the floor and slow his heart until the room goes dark. Number 7, the pea that waits for famine. There is a crop that keeps its promise only when everything else has failed. It is a modest climbing legume with a pale blue-violet flower, grown across the dry belt from the Mediterranean into South Asia. It has one extraordinary property. It does not fear drought. When the rains fail and the wheat withers and the other pulses shrivel, this plant goes on. It will grow on cracked, exhausted ground that supports almost nothing else. It will feed a family when there is truly nothing else to eat. Its name is the grass pea, Lathyrus sativus. It is one of the oldest cultivated plants in the human diet, grown in the Balkans by about 6,000 years before the Common Era. From there, it spread across the ancient world as a hardy insurance crop. The insurance has a price written into the seed. The grass pea holds a neurotoxin, an unusual amino acid known by the shorthand ODAP. In small amounts, mixed into a varied diet, it does nothing anyone would notice. The danger is dependence. ODAP overstimulates the receptors that healthy nerve cells use to catch a signal called glutamate. It drives them too hard, for too long, until the motor neurons that carry commands down to the legs begin to die. The disease it causes is called neurolathyrism. Greek physicians in antiquity already wrote that people who lived too long on these peas lost the strength in their legs, one of the oldest descriptions of a diet-borne disease anywhere in the written record. It has been recognized, in other words, for almost as long as it has been eaten. It does not kill. In some ways, what it does is worse. The victim is usually a young adult, most often a young man in the strongest years of life. It begins with heaviness and cramp in the legs. Then, the gait stiffens, the muscles pulling tight and refusing to release, until the person is walking on the balls of the feet, knees drawn together, hauling limbs that no longer obey. Many end unable to walk at all without support, and it is permanent. The nerve damage does not reverse when the diet improves. The person survives the famine and carries it in the body for life. The truly disturbing part is the timing. Consider the sequence. This is the plant that survives the drought. So it is exactly during famine that people turn to it. It is precisely when the family has eaten through everything else, precisely when they are weakest and most desperate, precisely when they most need the calories. That they eat this one crop still standing in the field. They eat it meal after meal, for weeks, because the alternative is starving. The grass pea does not poison people in good times. It waits. It poisons them at the very moment it is keeping them alive, and it takes its price from the survivors. It takes their legs. This is not history behind glass. Neurolithyrism has crippled people within living memory. It still appears in the poorest and most disaster-struck places on Earth, in parts of Ethiopia, Bangladesh, and India, wherever war or drought strips the diet down to this single stubborn plant. During the famines of the last century, from besieged wartime populations in Europe to drought years in the Horn of Africa, whole communities have gone lame within a single season. The young men worst affected because they ate the largest share. Agronomists have spent decades breeding a grass pea with less toxin. The low-toxin varieties exist, but the danger has never been fully bred out because the plant's toughness and its poison grow from the same biology. Boiling the peas and pouring off the water draws some of the toxin out, but in a famine, there is rarely the fuel, or the clean water, or the time to spare, and the peas go into the pot whole. The fields are still sown. In the good years, the grass pea is only a pea. It is in the ruined years, when people have nothing else and no time to soak it away, that it settles onto a nation's legs. Number 6. The Cycad. On the island of Guam, in the Western Pacific, doctors spent much of the 20th century facing a neurological catastrophe with no obvious cause. Among the indigenous Chamorro people, a devastating disease was killing at rates far above anything else on Earth. The islanders called it liticobodig. To Western neurologists, it looked like several of the worst diseases of the nervous system fused into one. It carried the muscle-wasting paralysis of ALS. It carried the rigidity and tremor of Parkinson's. It carried the mental decline of dementia. It ran in families and could take decades to show itself. And for a long time, no one could say why it clustered on this one island, in this one people. Suspicion settled, controversially, on a food. The Chamorro traditionally ground the seeds of the cycad, a squat, palm-like plant that is not a palm at all, but a survivor from the age before flowers. They made a flour from it that they called fadang. The seeds are known to be poisonous. They carry cycacin, a compound that damages DNA and is a well-established cause of cancer. They also carry a second stranger molecule, an unusual amino acid abbreviated BMAA. An American researcher named Marjorie Whiting spent years in the mid-century documenting the toxicity of cycad food. The neurologist and writer Oliver Sacks traveled to Guam and gave the mystery a book, The Island of the Colorblind. At its height, the disease struck the Chamorro at something on the order of 100 times the rate seen anywhere else in the world, and in some villages it stood among the leading causes of adult death. One influential later hypothesis argued the toxin was concentrated up the food chain, building in the flying foxes the Chamorro hunted and ate, so that a single fruit bat carried the poison of a great many seeds. Here, the honest thing has to be said plainly, because the science is not settled. The link between BMAA and this cluster of disease is genuinely contested. Serious researchers have argued the case for it. Serious researchers have argued hard against it. The critics point out that the exposure is difficult to measure, and that the pattern never behaved quite like a straightforward poisoning. What is not in dispute is smaller and firmer. The cycad seed is toxic. The Chamorro built elaborate washing to make it edible at all, and the disease was real and terrible. What stays open is how much of it, if any, the flour caused. Set the disease aside, and the cycad is still no safe food. Cycacin alone can wreck the liver and drive cancer, which is why every culture that ate the seed wrapped it in long washing and drying before it ever reached the fire. That uncertainty is exactly what makes the cycad so unsettling. Because the danger, if it is real, does not arrive with the meal. It arrives 30 or 40 years later. The people who processed the flour did so their whole lives. They did not fall down. The illness, when it came in old age, long after the eating, long after any reasonable person would think to connect the two. Cause and effect stood half a lifetime apart. That is the hardest kind of poison to ever recognize and the hardest to prove. And it is why the argument over this plant has run for 70 years without an end. Prehistoric people, remarkably, treated the cycad with more caution than any culprit theory would need. In Australia, Aboriginal communities built whole seasonal economies around cycad seeds and learned to strip the poison out through long leaching and fermentation. The archaeology of that processing runs deep. At a rock shelter in the country's southwest, evidence of large-scale cycad use reaches back around 13,000 years, which means people were carefully drawing the poison out of this seed at the very end of the last ice age. They ate a plant that could unravel the nervous system, and they worked out how to disarm it without any of the chemistry that still cannot fully explain it. The seed keeps its own time. It gives up its calories now, and perhaps presents the bill decades on, to a body that has long since forgotten the meal. Number 5. The flesh they buried to rot. Around 9,000 years ago, on the shore of a lake in what is now southern Sweden, people dug a long trench. They lined it with pine bark and seal fat. They filled it with fish, not to cook it, to let it rot in a slow and deliberate way, sealed from the air. A team led by Adam Boethius of Lund University excavated the site and published the findings in 2016. In that single pit, they counted the remains of tens of thousands of fish. They identified it as the oldest large-scale food fermentation ever found, thousands of years older than farming in the region. It tells us something that reaches far beyond one lakeshore. Fermenting flesh to preserve it is not the quirk of a few cultures. It is one of the deepest food technologies our species owns. In the far north, it took forms that are hard to describe without flinching. The best known comes from Greenland. Several hundred small seabirds, auks, are packed whole and unplucked into the hollowed, fat-lined skin of a seal. The air is pressed out. The skin is sewn shut and sealed with grease, and the whole mass is buried under stones for months. Slowly, in the cold and the dark and the absence of air, the birds ferment inside the seal. When it is opened in deep winter, the flesh has softened into something pungent and half-liquid, and it is eaten as it is. For the people who make it, it is a prized food and a source of nourishment when nothing grows and nothing else can be hunted. The dish itself is known mainly from the last 2 centuries of Arctic record, but the practice it belongs to, sealing flesh away to ferment, is old enough to predate farming itself. The trouble is that this is also a precise description of how to grow the deadliest poison in the natural world. The bacterium Clostridium botulinum lives in soil and sediment almost everywhere on Earth. It stays harmless as long as it stays dormant. But give it what it wants: an airless, low-acid pocket of decaying animal tissue, and it wakes and begins to manufacture botulinum toxin. That toxin is the most potent poison known to science. Its lethal dose is measured in billionths of a gram, so a quantity far too small to see can kill a grown adult, and nothing else in nature comes close. It works by silencing the nerves that tell muscles to contract, blocking the signal so completely that the muscles simply stop. The eyelids fall. The throat will not swallow. Then the muscles that drive breathing go still, and the victim suffocates, fully awake, inside a body that has been quietly switched off. But here is where the danger folds back on itself in a way that is almost unbearable to look at directly. Fermentation is not spoilage gone wrong. It is spoilage aimed on purpose at a useful end. How does anyone guard against a poison that grows in silence, in the dark, inside the very food meant to carry a family through the winter? The sealed, airless conditions that let the seal's skin preserve its birds through the winter are the exact conditions the botulism bacterium needs to bloom. Preservation and poison are not opposites here. They are the same process. Which one results depends on details no prehistoric cook could ever have seen. A trace of the wrong bacterium. A burial not quite airless enough. A season a few degrees too warm. The documented outbreaks in the modern Arctic are real and closely studied, most of all in Alaska, where fermented marine foods still send people to hospitals with the classic creeping paralysis, and where the toll over the decades is counted in deaths. The poison behind those cases is a kind that thrives in marine flesh, and they cluster precisely where the old fermenting traditions still run strongest. That is the recurring horror of the fermented food. The bacterium never left. It is in the soil under our feet right now, on every continent, waiting for a sealed and airless dark. The practice never left either, and the food is not poison. That is the whole point. It is safe 100 times, 1,000 times, nourishing and traditional and correct. Then, one preparation, in some quiet year, goes wrong in a way no eye can catch, and the meal that fed the village becomes the most efficient killer nature ever built. Number 4. The pufferfish. In the ancient shell mounds of Japan, the great heaps of oyster and clam shells left by the hunter-gatherers of the Jomon period, archaeologists keep finding a particular set of bones. They belong to pufferfish. The people of the Japanese islands were catching and eating pufferfish deep in prehistory. In the same centuries, they were leaving behind their pottery and their middens. It means one of the most dangerous animals ever put on a human plate has been food here for thousands of years. The pufferfish carries tetrodotoxin, and few substances in the living world are more precisely lethal. Weight for weight, it is commonly reckoned more than 1,000 times deadlier than cyanide, and unlike cyanide, it has no antidote at all. A single fish can hold enough to kill several grown adults. The poison does not spread evenly through the flesh. It collects in the liver, the ovaries, and the skin, and it does one specific, terrible thing. Like the mad honey in reverse, it seizes the sodium channels the nervous system runs on. But where the honey jams them open, this slams them shut, shutting off the nerve's ability to fire at all. The muscles lose their signal and go limp, and the paralysis climbs the body from the fingers and the lips inward. And here is the cruelty of tetrodotoxin. It does not touch the mind. The victim stays fully awake and fully aware, unable to move, unable to speak, unable at last to breathe. Conscious to the end. There is no antidote. The only treatment is a machine to breathe for the person, and time, and the hope that the poison lets go before the body gives out. Where does such a poison come from? Not from the fish itself, as it turns out. Tetrodotoxin is built by bacteria, and the pufferfish accumulates it from what it eats, banking a chemical weapon it did not invent. That detail matters, because it means the danger is baked into the animal's flesh and organs, not something that can be rinsed off or cooked away. Heat does nothing to it. Boil the fish, grill it, freeze it for a year, and the tetrodotoxin is exactly as lethal as the day the fish was pulled from the sea. Except that the middens leave us with a hard question they cannot answer. The bones prove the Jomon ate pufferfish. They do not prove the Jomon knew how to eat it safely. Preparing this fish is not a matter of care. It's a matter of exact anatomical knowledge, cutting away precisely the organs where the poison hides without nicking a single one. In modern Japan, that skill takes years of training and a license, because the margin for error is essentially zero. It is entirely possible that some of those prehistoric meals were the last their eaters ever had. It is possible the knowledge of how to handle the fish was bought over generations with the lives of the people who got it wrong. The archaeology hands us the appetite. It stays silent on the cost. And the danger has not aged a day. Pufferfish, served as fugu, is still eaten in Japan, still governed with extraordinary care. Chefs train for years and hold a license before they may serve it. Even so, a handful of people still die in a typical year. Almost all of them prepared the fish themselves, at home, and got a single cut wrong. There is even a long-running and largely discredited claim that this same toxin in tiny doses lies behind the folklore of the Haitian walking dead, a theory most toxicologists have taken apart. Strip away the sensational version, and the plain fact is stranger. Here is a fish that human beings have chosen to keep eating for thousands of years, knowing exactly what it can do, because prepared correctly, it is harmless and prized. Every plate of it is an act of trust, placed in the steady hand and exact knowledge of whoever made the cut. Get that trust wrong once, and there is no second try. Number 3, the first bread. In 2018, archaeologists sieving the ash from a stone fireplace in the Black Desert of northeastern Jordan announced they had found the oldest bread in the world. The site is called Shubeka 1. The charred crumbs recovered there, studied by a team from the University of Copenhagen and University College London, were roughly 14,400 years old. That is the staggering part. This bread was baked by hunter-gatherers, by Natufian people who had not yet invented farming, some 4,000 years before anyone planted a field. They gathered wild einkorn wheat and other wild grains. They ground them, mixed in the ground tubers of a marsh plant, and baked a thin, unleavened flatbread on hot stone. In itself, that loaf was not dangerous at all. It is what bread led us to become that belongs on this list. Because once human beings made ground grain the foundation of the diet, they took on a set of dangers that came bound to the grain. They committed to it. They built cities on it. And the grain extracted its price. The first danger was mechanical and relentless. To make flour is to grind grain between stones, and the stones shed grit, fine particles of quartz and rock that end up in every batch. Prehistoric and early farming teeth show the result with brutal clarity. They are worn flat, ground down through the enamel to the softer core beneath, filed away by a lifetime of chewing stone along with the bread. The staple food sanded down the teeth of the people who lived on it. The second danger was alive, and far worse. Damp stored grain is an open invitation to a fungus called Claviceps purpurea, ergot. It hollows out the kernel and replaces it with a hard, dark growth packed with powerful alkaloids. Eat enough, and the result is ergotism. Ergotism comes in two forms, each nightmarish in its own direction. One clamps down on the blood vessels so hard that fingers and toes and whole limbs lose their supply and rot on the living body. A dry gangrene that medieval Europe came to call St. Anthony's fire. The other brings convulsions, crawling sensations beneath the skin, and hallucinations wild enough to pass for madness. And this is not only a later problem. We have prehistoric stomachs to read. The bog bodies of northern Europe preserve their final meals. The Tollan man's last supper was a plain porridge, mostly barley. In the gut of the Grauballe man, among a gruel of more than 60 plants, researchers found actual grains of ergot. What makes that discovery worth handling with care is where the honest line falls. The museum that holds the Grauballe man is careful to say the amount of ergot in him was small. It was too little to have poisoned him, or to have filled his last hours with visions. So this is not the story of a man drugged before a ritual death, however often it is told that way. It's something quieter, and in its own way, heavier. It is a trace, a few dark grains, in a 2,000-year-old stomach. It shows that the poison already rode along with the food, latent in the grain store, waiting for the wetter year and the larger dose that would turn a harvest into an epidemic. The full horror of ergotism arrives later in the written record, in mass outbreaks that emptied whole districts, one of the first of them sweeping the Rhineland in the 9th century. And in a final twist, the same fungus became a wellspring of modern medicine. Its alkaloids were refined into drugs that stop bleeding after childbirth and ease migraines, and, in a Swiss laboratory in 1938, into the compound the world would come to call LSD. The warning was already there in the porridge. That is the strange inheritance of the first bread. The loaf from Shubeka was a triumph. the beginning of the food that would carry civilization. It was also the beginning of a bargain. Tie your survival to grain, and you tie it to the grit that wears the teeth flat and to a fungus that can burn a body from within. Dangers the first farmers could neither see nor name. We still eat the descendant of that flatbread every single day. The only difference is that we now know what can hide in it and stand guard in a way that 14,000 years of people before us never could. Number 2, the liver they refused to eat. William Barent's crew had been trapped in the Arctic for months when they made the mistake. It was the winter of 1596 and 1597. The Dutch expedition was stranded on the frozen edge of Novaya Zemlya, far above the Russian mainland, living in a driftwood hut against a cold that could kill in minutes. They were desperate for food, and they killed a polar bear. Some of the men ate its liver. Within hours, they were gravely, frighteningly ill. In the account left by the crewman, Gerrit de Veer sits one of the most vivid details in the history of Arctic survival. Their skin came off, peeling away in sheets, from the foot to the head. They expected to die. Somehow, they lived, and they had just set down, for the first time in European records, the effect of a food that the peoples of the Arctic had known to avoid for thousands of years. The poison in polar bear liver is not exotic at all. It is vitamin A. The animals at the top of the Arctic food chain store vitamin A in their livers at concentrations found nowhere else in the natural larder. A polar bear liver can hold tens of thousands of units in a single gram. A normal serving of it can deliver a dose hundreds of times greater than a person can safely take. In 1943, in the Biochemical Journal, the researchers Rodal and Moore established that vitamin A itself was the culprit, and that even small amounts of the liver were toxic. The gap between a safe portion and a poisonous one is brutal. A person needs only a few thousand units of vitamin A in a day, and a single ordinary helping of polar bear liver can carry hundreds of times that much. A sudden flood of it does exactly what the Barents crew suffered. It raises the pressure inside the skull until the head splits and the body sinks towards stupor. It turns the stomach, and it makes the skin die and slough away. And no preparation helps, because heat does not destroy vitamin A. You cannot cook this danger out. The liver is poisonous, cooked, raw, or frozen. But here's where the story turns from a warning into something far more impressive. The outsiders were the ones who got poisoned. The people who actually lived in the Arctic, and had lived there for millennia, did not. The ancestors of the Inuit had been killing seals and bears across the top of the world for longer than is easy to picture. The Thule, the direct forebears of today's Inuit, spread across the North American Arctic roughly 8 centuries ago, and the Paleo-Inuit hunters before them had worked these coasts for thousands of years more. Their cultures carried a simple, absolute rule. You do not eat the liver of the polar bear. You are wary of the liver of the bearded seal and the sled dog for the same reason. No one among them could have named retinol, or the pressure it raises in the skull. They did not need to. The knowledge had been compressed into a prohibition, a taboo, handed down the generations intact, doing its protective work without a word of chemistry attached. The rule was the science, stored in a form that could survive being passed from a grandmother to a child. The same avoidance appears independently among Arctic peoples separated by thousands of miles, from Siberia to Greenland, a measure of how reliably the lesson had been learned and kept. Think about what that means for how prehistoric people actually stayed alive. Not everything they knew came as a recipe, a way to make something edible. Some of the most important knowledge came as a refusal, a hard line drawn around a food that looked perfectly good and would sicken or kill, learned at a cost paid by someone long ago, then remembered by everyone since. How many of humanity's oldest food taboos are exactly this? Frozen survival lessons whose reasons were forgotten while the rule itself lived on. Not every case is settled, and honesty demands the caveat. The often told story that the explorer Xavier Mertz died in Antarctica in 1913 from eating the vitamin-rich livers of his sled dogs is genuinely disputed, and modern reanalysis argues that plain starvation is the likelier killer. But the core lesson stands on firmer ground than any single expedition. In the Arctic, the most important thing a hunter could know about the richest organ of the largest animal he could bring down was to leave it in the snow. The deepest food wisdom was not what to eat, it was what to refuse. Number 1. Cassava. Hans Rosling had been a young district doctor in northern Mozambique for only a short time when the paralysis arrived. It was 1981, in a poor rural region, in a hungry season. Suddenly, people were being carried to him who days earlier had been walking. Their legs had stiffened and locked, drawing tight, refusing to bend, and they would never move normally again. There were hundreds of them, and they were overwhelmingly children and young mothers, the youngest and most essential members of their communities. The local people already had a name for it, because it was not entirely new. They called it konzo. The word means tied legs. Rosling would spend years on the mystery, building his doctoral work around it, and what he uncovered turned an obscure tropical disease into one of the clearest and most disturbing lessons about food our species has ever been handed. The cause was on every plate. It was cassava, also called manioc, the thick, starchy root that is one of the most important foods in the tropical world. For hundreds of millions of people, it is a primary source of calories across huge stretches of Africa, South America, and Asia. Bitter cassava contains a compound called linamarin. When the root's tissue is broken, that compound releases hydrogen cyanide. The human body can defuse a certain amount of cyanide, but only by spending sulfur drawn from protein in the diet. Rosling watched the whole grim equation click together. In drought and famine, families ate cassava that had been rushed through its cleaning to save time. They ate almost nothing else. There was no protein to spare, so the cyanide went undiffused and struck down the long nerves that carry movement to the legs. The result was permanent. Konzo does not fade. The disease had first been described decades earlier, in 1938, by a physician in the Belgian Congo, who simply wrote down the word the local people were already using. By the time Rosling finished his work, tens of thousands of cases had been recorded across Africa, and researchers suspected the true number, hidden away in remote villages, ran far higher. The history of this root reaches almost unimaginably far back, and so does the human answer to it. Cassava was domesticated in the Amazon. The earliest solid evidence comes from microscopic plant remains, identified in a study published in the journal Nature in 2020. They were found on forest islands in the Bolivian Amazon. They are around 10,300 years old. Genetic work traces the whole domesticated species to a wild ancestor on the southern rim of the Amazon basin. And here is the thing that should stop you. Those ancient Amazonians were growing a root that could kill them, and they had already worked out how to strip the poison from it, with no idea that cyanide existed. They grated the root to a wet pulp to rupture its cells and let the toxin out. They packed the pulp into a long, woven tube press called the tipiti. They pulled it tight so that it squeezed like a finger trap and wrung the poisonous liquid out of the mash. What was left, they toasted into flatbread. Even the deadly juice was not wasted because boiled long and hard enough, it drove off its cyanide and became a prized sauce. A lethal chemistry problem, solved by process alone, thousands of years before there was any such thing as chemistry. And this is the truly haunting reason cassava sits at number 1, above every ancient and buried thing on this list. Its danger never became history. This is not a food behind museum glass. Cassava feeds hundreds of millions of people at this moment today as one of the primary staples on Earth. And konzo has not stopped. It still strikes right now in the Democratic Republic of Congo, in Mozambique, in the Central African Republic. It strikes under the exact conditions Rosling identified: drought and war and hunger. The moments when frightened families are forced to shortcut the very processing that keeps the roots safe at the precise moment they depend on it most. The paralysis still falls on children. That long chain of grating and pressing and toasting, the oldest food safety knowledge our species ever worked out, is still the only thing standing between more than 1 billion daily meals and a cyanide poisoning. Every time that knowledge is skipped in a crisis, the legs of the youngest pay for it. That is what sharpens cassava to a point the rest of this list cannot match. The acorn's leaching is nearly forgotten now. The bog butter lies in its peat. The mad honey and the pufferfish are dangers a person can choose to avoid. But cassava is on the table of a large share of the human race every single day, carrying the same poison it carried 10,000 years ago in the Amazon, made safe by the same ancient procedure and by nothing else. We did not outgrow this danger. We inherited the solution to it, and we have to keep that solution alive, hand to hand, parent to child, generation to generation, or it returns exactly as it always has. The root feeds more people now than in all of prehistory combined, and the paralysis it leaves in the legs of a hungry child is precisely, unchanged, the same. If you want to see more videos like this, click the video on screen now and make sure to subscribe.